Since 1945, clients have counted on Jakes International for expert, safe, and cost-effective solutions for their ultra-heavy lifting and hauling needs. Recognized as a foremost specialist in ultra-heavy highway transport, we earned our reputation by safely moving the largest cranes, transformers, turbines, generators, crushers, and vessels. State-of-the-art technology and advanced engineering assure our customers that loads will be securely and safely moved on schedule and within budget. Late in 1988, Jakes was invited to bid on moving a massive autoclave from Salt Lake City to the Barrick Gold Strike mine northwest of Carlin, Nevada. The bid papers described the load 75 feet long, 17 feet 8 inches high, 15 feet 6 inches wide, and weighing 330,000 pounds. We had just developed the JXS, our patented high-speed, ultra-heavy transport system for on and off highway applications. We knew we could easily handle the weight with legal axle loadings. The challenge was to devise a viable route and a load support system for getting such a large and heavy load under, over, or around all the bottlenecks likely to be encountered. These companies were involved with the project. Kilbourne Engineering, Toronto, Ontario, Canada, performed the overall engineering for the mine site and acted as construction manager and agent for Barrick. Stebbins Engineering and Manufacturing Company, Watertown, New York, supervised the fabrication of the vessel and contracted its haul with Jakes. Eaton Metal Products, Salt Lake City, Utah, fabricated the vessel under contract with Stebbins. Even before the purchase order for the haul was issued, Jakes was hard at work planning the project. Each government agency en route was contacted to determine the rules for the load, to evaluate alternative routes, and to start the process of getting permits. Preliminary surveys were conducted to determine route feasibility. Hours were spent by Jakes' engineering team projecting loaded heights, lengths, and axle loadings. The basic JXS transport has a pair of rigid frames over multiple axles, each with a hydraulic pneumatic suspension system that provides axle load equalization. The JXS also has all-wheel steering and braking for safe maneuvering. Its rigid platforms can support loads directly or use modular load support structures such as goosenecks and beds, schnobbels, and side beam bridges. The JXS was perfectly suited for this project. The JXS has other unique features. Large loads must have load tilt and attitude control. Automatic phase steering, crab, and radial steering are selectable for tight maneuvering. With these features, the JXS can safely handle loads up to 250 tons at freeway speeds, with legal axle loads and 50% more off-highway. The JXS can be configured with modules for 11 to 21 load-carrying axles, excluding the push tractor. Tread width can be 12 or 14 feet. The modules allow the JXS to easily adapt to virtually any heavy haul job on highway or off. The most unique innovation is the JXS patented suspension. The design concept was inspired by the landing gear of the Boeing 747, handling heavy loads and absorbing impacts at high speeds. We adapted it by allowing individual units to be positioned at different points on the trailer's frame and by designing in a load equalization mechanism. A novel hydraulic cylinder suspension system with nitrogen accumulators was developed. Called a JXS assembly, each four-tired suspension unit has a 6-inch cylinder with an 18-inch stroke. Each axle line is composed of two JXS assemblies connected to the rigid trailer frame. The assemblies steer, brake, and absorb all vertical, rotational, and moment loading independently. The integrated use of hydraulic fluid and nitrogen coupled stability and a high carrying capacity with instantaneous response to the road for an extremely soft ride, effectively eliminating point loading. When planning started, we chose a JXS 17 axle configuration. This yielded a bonus purple loading with a limit of 66,700 pounds per 14-foot wide, 16-tire group in accordance with both Nevada and Utah guidelines. This eliminated the need for special permission for unusual loadings. To support the autoclave, we developed a novel structure marrying the Schnabel approach with side beam bridges. Beams were designed to extend from each fifth wheel along the side of the autoclave, approximately 1/3 its total length from each end. They would be attached using 1 1/8 inch cable lashing. The inboard lashings would bear down on the top of the vessel, while the outboard ones would bear up on the bottom. The resulting forces give support in a Schnabel-like fashion, minimizing overall height and saving weight. Conventional hydraulic dollies would transport the autoclave from inside the fabrication shop to the loading area. Once in position, the support beams would be assembled around the vessel. By using the hydraulics of the dollies and the JXS suspension, the load would be transferred to the JXS and the dollies removed. Once the customer made a firm commitment to proceed, the specialized planning began. All the minute details required to accurately present the plan to the customer and to determine final fixed pricing were covered. Meticulous calculations were made to determine loading height. We would need enough height adjustability to prevent dragging during over-the-road movements. Several vertical curves would have to be carefully measured to precisely calculate the geometry. The route was surveyed again in far more detail. Signposts, utilities, and other obstructions that would have to be temporarily moved were noted. Both states' authorities were consulted regularly for their input and agreement as the route plan developed. With the survey, each structure and difficult corner was identified by number, with photographs and complete measurements. Every bridge clearance of less than 20 feet was measured in the middle, in both lanes, and on both shoulders. A way was found under many structures that would not have been passable according to posted heights. The nearby geometry of the road was also important, as any change in road surface could change the clearance by several inches. The route survey book virtually eliminated problems and surprises once the move began. All the agencies cooperated willingly. The planning process gave them confidence in the route, but there were other problems, major ones. Detailed route measurements confirmed that to make the direct route feasible, the range of load height adjustability needed to be more than the JXS available 18 inches. Suspending the load low enough to clear overhead obstructions created problems raising it high enough to clear several of the vertical curves and super elevations en route. Jake's engineers determined that by placing 4 100-ton hydraulic jacks at the ends of the support beams, the load could be raised an additional 16 inches for a total of 34 inches. With that solved, fabrication of the beams and support fixtures began. The beams were made of T1 steel to reduce weight. The schedule demanded speedy design and fabrication, so it was all done in-house to best assure quality T1 welds and tight project control. Later, we faced a bigger problem. Just 2.5 weeks before the load was scheduled to load, the customer called and informed us that the weight had changed from the original 330,000 pounds to an unbelievable 425,000 pounds. This last-minute 95,000-pound increase seemed to be an insurmountable problem unless we could extend the project. But the customer was on a tight schedule, and that required the autoclave to be there on time. A weight increase this great hatches many concerns, among them the supporting structure, the 17-axle carrier, the axle loadings, the permits, and the vessel's capacity to take the added stresses. Jake's engineers determined that the beams would carry the increased weight. The 17-axle carrier's capacity was more than ample, but the axle loadings would now be well over limits. Given more time, switching the JXS to 21 axles would have solved the axle loading problem, but it would mean longer support beams requiring time-consuming and costly redesign and fabrication. It would also mean reevaluating the route for a vehicle 36 feet longer than before. The only timely solution appeared to be adding 4 conventional dollies below the support beams. Using belly bands we could quickly design and fabricate for that purpose. They would be tied into the overall hydraulic nitrogen suspension system for axle loading equalization. Suitable dollies, originally designed and built by Jakes, were available from Almus International of Chino, California. The sharp turns on the 12% grade of the mine access road could not be negotiated with dollies in use. The load would swing out over the canyon embankment during the sharper turns. But once on the private mine access road, the dollies could be removed legally. The new weight was discussed with officials from both states. With the dollies, the JXS met all requirements for axle loadings. Permits were issued. The added weight would increase stresses on the vessel from the cable lashing. To ensure the vessel's integrity and to maintain its roundness, internal bracing was designed and fabricated at Jakes for installation before loading. The JXS and its crew left Las Vegas on time to begin the loading and transport of the vessel. Delivery was guaranteed on or before June 17, 1989. The crew arrived at Eaton's shop to find the autoclave ready to go. They jacked it up and positioned dollies to pull it out for painting. While it was being painted, they installed the internal bracing. The vessel was then carefully moved on from Eaton's yard to the more spacious nearby yards of Savage Incorporated, which they graciously let us use for transloading onto the JXS. Two small cranes from Shirtliff and Andrews of Salt Lake City helped assemble and lash the supporting beams to the vessel. After close dimensional checks were made, the weight of the vessel was hydraulically transferred to the JXS. The vessel was positioned exactly as planned, with maximum adjustability to both clear vertical curves and underpasses along the route and be unloaded at the mine site without the use of heavy cranes. Late Saturday afternoon, June 10, 1989, the enormous vehicle began moving out of Savage's yard and into position to move over a curb, through a fence, and onto a divided highway early the next morning. Day 1. At first light, all conditions were go. The Highway Patrol agreed to block the highway, but only for 15 minutes. The JXS jumped the curb and turned smoothly onto the highway, and traffic resumed in just 11 minutes. Except for a few minutes in a tunnel east of Carlin, Nevada, this was the only time that highway traffic had to be blocked. The JXS rolled on through the arterials of Salt Lake City, completing more critical turns by midday when the load was finally heading west on Interstate 80. JXS stands for Jakes Extra Speed, but in this case, remember, the JXS is 262 feet long, 21 feet wide, 18 feet tall, and weighs over 700,000 pounds. So speed was prudently kept at about 35 miles per hour on the open stretches. Nice and safe, yet not so slow as to unduly interfere with traffic. Several problem underpasses were avoided using the ramps. The route survey proved invaluable to the crew. They were confident. Each structure was clearly identified. Each action planned. Everyone knew what to do. Because of a 16-foot underpass, we ended day 1 with a 27-mile detour from Interstate 80 through the town of Grantsville, Utah. Local utility company personnel were waiting to lift all wires. Jake's custom escort and mechanic truck was also there, fully equipped to keep the JXS going. Each night, Jake's mechanics checked all 164 tires for wear and air pressure. Each night, the entire JXS was carefully inspected. Each night, the full JXS crew had a tailgate safety session to review details for the next day. Day 2, there were more detours for low bridges. One included the sharpest corner on the trip in exiting onto a 15-mile stretch of gravel frontage road at the Aragonite interchange. The crew removed all road signs and the JXS started to turn. After a 90-degree right turn off the exit ramp, a 90-degree left turn had to be started before the rear end had completed the first turn. These detours required intricate steering and the complete coordination of tractors and tillermen. With the JXS twin rear steering cabs, cornering blind spots are eliminated. The tillermen have full view and control from either side, including control of tilt of the load. Day 3. The load entered Nevada. The steep grade to the 6,900-foot Pequot summit gave the tractors a good workout. but it was no match for the JXS 1400 horsepower. We crested it by 6 p.m. Day 4, too, went as planned. The time and care spent in preparation paid off, as can be seen with the bridge clearances like this, with no margin for error. Instant communication and close coordination are critical in maneuvers like this. All crew members, police, and escort vehicles were linked by two-way radios. Day 5, the tunnel at Carlin, Nevada was on the schedule. Westbound traffic was stopped briefly to allow the load to move directly down the center of the tunnel. It had to clear the sidewalls. Day 6, the JXS left Interstate 80 for good and moved 12 miles up a two-lane road to a turnout waiting area at the Mine Access Road turnoff where the dollies were removed. The JXS could not use the private mine road until Saturday due to worker traffic. Day 7 first brought a tortuous 7-mile journey up a two-lane road with steep 12% grades, compound S-curves, and 15% super elevations. The load moved up the canyon without incident. The push and pull tractors inched the load throughout the steep grades and around the treacherous corners. There was more than enough power to stop and restart. The road tested the skills of the JXS crew. The front trailer might be in a left turn with super elevation to the left, with the rear still in a right turn on a different grade with super elevation to the right. Drivers and tillermen paid careful attention to the load and manipulated all 4 jacks to keep it level. While the trailers twisted and turned, the load stayed on an even keel. The last 4 miles were down a huge gravel mine haul road, and after the uphill 2-lane road, it seemed like an interstate. The JXS entered the ore processing area, and the autoclave was driven onto its foundation precisely over the anchor bolts. Saturday evening, June 17, 1989, just 7 days after leaving Salt Lake City, the journey was completed on schedule. Sunday morning, installation of slide plates was completed, and the vessel was permanently set to rest. All of the careful planning allowed the autoclave to be placed gently yet precisely where it belonged. Altogether, from start to completion, the project consumed 150 highway patrol hours, 150 escort hours, 400 engineering man-hours, 1,500 fabrication man-hours, 900 crew man-hours, and 200 supervision man-hours, a total of 3,300 man-hours. No one was injured throughout the entire job, save one minor first aid case involving a cut finger. Jakes is proud to have had this opportunity to demonstrate its JXS and skill. Our team faced some tough challenges, but by applying state-of-the-art techniques and concepts, we employed a safe, stable vehicle that cushions the load, resists rollover, equalizes axle load, supports nearly anything, and places its load precisely where it's wanted without jacks or cranes. When challenged by highway geography and geometry, we devised a supplemental jacking system. And when confronted by a last-minute 95,000-pound increase in load weight, we responded creatively, legally, and on time. Builders of the JXS, our fabrication team, when faced with these crunches, delivered the solutions. Finally, our thanks go to all the members of the JXS crew, drivers, tillermen, and mechanics who put in consecutive 14-hour days driving and maintaining the JXS. The many hours of planning, surveying, photographing, evaluating, the countless meetings were all worth it when the job was done, on time, within budget, and without incident. Clients with ultra-heavy rigging challenges have long looked to Jakes International for expert, safe, innovative, and cost-effective solutions. Recognized as a foremost specialist in rigging design and fabrication, our reputation is sustained by state-of-the-art engineering technology and worldwide project experience, assuring our customers that their jobs will be safely completed on schedule and within budget. In November of 1988, Olson Beal engineers and constructors from Linden, Utah, contacted us about a job they were bidding in southeastern Utah. The job would be located 60 miles east of Salina, Utah, where Interstate 70 crosses Eagle Canyon, and entail constructing a 500-foot span steel arch bridge for the westbound lane. The eastbound lane was constructed in 1962. Olson Beal asked Jakes to 1. Make an erection study, 2. Devise a safe, economical, and feasible method to erect the bridge, a method that would offer complete adjustability during construction. 3. Come up with a lump sum rigging quote and a bare rental craneage quote. 2 major questions had to be answered. First, how to support 500-foot twin steel arches during construction, and second, how to set the ribs into place. The existing bridge had been constructed using temporary towers to support the arches and a cableway to place the ribs. Because of Olson Beal's requirements for economy and adjustability, we quickly eliminated traditional methods of arch support from consideration. Supporting the 16 rib sections per arch with shoring was out due to the 200-foot depth of the canyon. Rather than employing stationary towers as had been done in 1962, Jakes proposed using 40-foot wide by 120-foot high temporary luffing towers for added adjustability. The towers would be located just behind the abutment on each side of the canyon. The foundations for the towers would be incorporated